check. Okay, hello, welcome back to another session of Python. We were seeing the tuples and list, and today we're ready. We're going to check the sets, and we will start with the for loops, and we will see the while and functions. So let's move on. Today is gonna be probably a long video. Okay, I should start with the tuples. Okay, let's move it here. Let's put tuple. No, the tuples not. Sorry, we see the sets. We want to check the sets. We already did the tuples. Here, sets. Okay. No, these exercises are not sets. Yeah, okay, sets. Sets.py. Come on. .py. Okay, so what is a set? A set is a structure that stores unique elements. If you add repeated values, Python removes them automatically. Unlike a list, also the set does not guarantee an order. So what it means, let's create a list. Let's put my list. My list is going to be, for example, camera, can be GPS, and can be also radar. Okay, this is just a list. What it means that the set does not guarantee an order, because if we go here we say print my list, as we saw in the previous class, and then we say okay, from my list I want camera. We all know now that camera is the index 0, right? If we print this, we get camera in here. So with the list, in this case, in my list, camera will always be the index 0, GPS the 1, and radar the second one, and that will be like this unless we modify it. Like we can add more, we can change positions, so this in the previous class. But if we don't modify the list remains the same. With the sets, it doesn't happen. The sets are more random. If you add something, it will go into the random position, and we will go into that. Okay, so we say that this is a list. Okay, now we also can say that this, my tuple, is a tuple, and we make a tuple in here. List it with the square brackets. Tuple, we say this with parentheses, right? And the tuple can be 40, 70, and whatever, all the values that we want to put. And now we want a set, so we can say my set. Remember, you can put here any number, right? You can put elephant, you can put my list if you want as a name. It's not not a good idea because it can confuse you, but you get the point. You can put any name in here. In this case, to make it more clear, we're gonna put my set. And how is the set? We start the sets with the curly brace. Everything inside the curly brace is a set. And what can be set? A set can be 80, can be camera, and can be 70.5, right? Let's print my set. And something is wrong. Line 4. What happened in here? Print my set. Oh, it was indented. Okay. Now we print, we see that inside the curly brace we see the 80, the camera, and the 70.5. So let's move on. What can we do with the sets? Okay, so as we say, it does not accept duplicates, right? So we can put my set is going to be, let's open the curly brace, and then we put 60, 70, 60, and 70 again. And now we say, hey, I want to print my set. Then we print it, and we have here 60 and 70. So even knowing that we created a set in the first place saying 60, 70, 60 and 70 again, once we print it, it only gives 60 and 70, because we said every duplicate is automatically deleted by Python. So sets does not allow duplicates. Okay, what this can be good for? This is one of the most useful uses of set. We convert a list with repeated values into a unique set. So if we make a list with in the list we have a lot of duplicated values, it can happen, right? So then we say we want to delete all repeated values that we have in a list to clean the list. Then we can transform the list into set, and all the repeated value will be deleted. Let's check one example here. Let's put for example detected sensors is equal to, let's make a list and put camera. We can put GPS, we can put camera again, we can put radar and GPS again. Okay, this is a list and we have repeated values in here, and now we want to delete those, we want to clean the list. Okay, so we say unique sensors, make send the variable, right? Because now we want to work with only unique sensors, we don't want repeated sensors on the list. So unique sensors is equal to a set, because we want to create a set, and in the set, the documentation in that, the set is going to be the name of the list that we want to convert, right? In this case it's detected sensors, so we put detected sensors in here, and now we print unique sensors is what we want to print, right? Because it's what we have now, it's the set that we have created. So unique sensors, and we print it. What is wrong here? Okay, now we have it, and we have in curly brace, I like to call it curly bracket, like curly brace, it sounds better than curly brace. Okay, curly brace, GPS, camera and radar. We have GPS, camera and radar. The camera that is duplicated and the GPS that is duplicated is not in the list. So now we can say, okay, we clean the list, and now we can say unique sensors, which is our set. Unique sensor, unique sensor list, because now with unique sensor that it was a set, we want to make a list because are the unique sensors that we want to work with, right? So unique sensor list is gonna be a list with the values of unique sensor. Remember, unique sensors is not the same as unique sensor list. Okay, the variable, the name is different. So basically we are saying, okay, I'm gonna create a new variable that is unique sensor, and it's gonna be a list. Unique sensor list is not a list because we put list in here. It's gonna be a list because we put list in here. But this is to make sense, just to put a name that will make sense. And we say, okay, this variable I want to be the conversion of the unique sensor into list. And now we can say print unique sensors sensor list. And we print. You see, we have in curly braces camera, GPS and radar, and now we have camera, GPS and radar in a square bracket. So first one is a set, and the second one, this one, is again a list. What else can we do with the sets? Let's delete the list. And let's put sensors equal to a set. Let's make a set with camera and radar. Just these two values. Remember that we have to put a comma in here. Okay, and now we say, okay, let's say that I want to add any other value, so I can say sensors dot add, and what I want to add, I want to add another value called GPS, for example. We don't have GPS on top, right? We don't have it. And now print sensors. Oh, just to make sure that we see the difference here, let's print sensors on top so we can check in the console the difference. We print again, we have here camera and radar, and now we have GPS, camera and radar. You see, in this case GPS is on the first position. With the sets we don't have 0, 1 and 2. There is no 0 index in the set. I think this documentation should be here. Let me check. Yes, exactly. So basically the difference between the list and the set is the list keep the order and the set does not depend on the order. We already said that, and we're gonna have to look into it right now. It said that the list allows duplicates and the set does not allow duplicates. And here it says that the list it has 0 index and there is not 0 index. It doesn't exist on the set. Okay. So what we wanted to see in here? Okay, that is not following an order. So if we print this again, you see exactly the same. We didn't change anything, and in here it was camera rather than GPS. Oh wait. Well, it's okay. It's okay. It's just we just put an extra parenthesis, but because the parenthesis that we put extra is inside of the string. I think this is something that we saw in the first class, right? Everything that will be inside of the string, every text that will be inside of the string, it will be printed just like that. Like Python doesn't even know what is in there. It just say, okay, whatever is between the strings, I'm gonna print it. Between the quotation marks, I'm gonna just print it as it is. So, okay, it's okay. We have what I wanted to say. We have camera and radar here. Now we have GPS, camera and radar. Okay, we have the first one, radar and camera, which is also different order, and radar, GPS and camera, which is also different order. So it's not always in order. You can print it 1000 times, and 1000 times can be given random positions to every element or to every value. Okay, so this is basically like the append with the list, right? With the append with the list, the append, if you remember, you add a value to a list using append, and then it will go exactly to the last position. Here is the same, but it just goes to random position. So you can use append with the list, and you have add with the sets. let's check a different one. Let's put extra space here and let's clean GPS. Let's put it right. Okay, what do we have? We have update, so we can put like sensors dot update. And now in update, this could be a bit confused, but with the update, okay, update is with parentheses because it's an instruction word, and we said every instruction word in Python has parentheses. But now we open square brackets in here because we want to add more than one value. And we can say we have camera and radar, so we can put the GPS, for example. And then we also want to add like microphone, just to say something, right? Microphone. And now we print it. And we have the first print, sensors, normal, and then we have radar, GPS, camera, and microphone. So this is going completely random positions, but the thing that you need to get used is when you're using more than one value with the update, you also need to put the square brackets, because I think this is not working without the square brackets. We can just give it a try and see what happens. Okay, I think what happens in here is that those two words, which is every single text inside of the quotation marks, if you don't use the square brackets, it also works, but it gives you only the letters individually, and because it doesn't accept duplicates, I think these are all the letters that will form these two without counting them, the repeated letter, without repeating the letters. So it's not a mistake. I mean, it is a mistake, but at least it doesn't break the program. It's just not working as you would like it to work. Can we just put the brackets here? Why does it happen? So you have to remember to put the square brackets in here. Now you have it in here. So in the list for this we have the extend, if I remember correctly, yeah, the extend. So in the list that we saw in the previously class, we use extend if you want to add more values. Here with the sets is the same, but instead of using extend, you use update. The only thing that you need to remember is to always use square brackets, otherwise this happens and that it will go to random position. Okay, same as the list, we can also delete something. Let's say sensors.remove, and then we want to remove camera, for example, and then we print sensors. Let's say we have radar, camera, and now we only have radar. Camera has been deleted. But let's say that I want to keep going with the code, and I say, okay, now I want sensors remove. Did I put it right? No, it's not like remove. Oh, okay. This should be working now, right? So remove, and I want to remove camera again. I want to know why this is not. Okay, now it's working. Okay. So sensors, I want to remove camera again, and now I'm gonna print sensors. If we check the code, we have the normal print of the sensors. We didn't modify anything, we just created a set called sensors, and we want to print it. In the line 5, we created code saying sensors, I want to remove camera. In the line 7, we just print this one. And then in the line 9, we say it again, I want to remove the camera. and I want to print the sensors. And it said that there is a mistake in the line 9. What happened in the line 9? That I tried to remove something, to delete something in the set that it was previously deleted. So it gives an error. So it could happen that we want to delete the stuff from a set, but we don't know if this is in the set or not. Maybe someone else deleted if we are working with the team and we don't know, and we want to delete this thinking that no one deleted before you, and then after 200 lines of code, hey, there is a problem. What is the problem? We don't know what the problem is. So in this case, what I suggest is, in this case, we remove the new, use discard. If you put sensors, discard is to delete also. But what is the difference between remove and discard? Okay, discard say to the program, hey, in sensors, I want you to check for camera. If the value camera is in the set, I want you to delete it. But if you go through the set and you don't see camera, it's okay. Just don't break the program and keep working. So we print now and we see camera and reader. In the line 5, we already deleted the camera, but we tried to delete it again in line 9, but there was no camera already. So Python read it and say, okay, I'm gonna delete camera. There is no camera because at this point, camera was already deleted. It was just showing you radar, so you say, okay, the only thing that I could find is radar. There was no camera, but the program doesn't break. It just keeps working. Okay, let's keep moving with this. So we said operations, union and intersection. I'm not sure if I want to do that now. This one can be a bit confused now, because basically the union and intersection is pre-calculus in math. It's like adding already pre-calculus into the Python basics. I explain it in Spanish, but really make not much of sense. But let's say that I want to divide maths in general into two. Okay, I will say pre-calculus, which is the foundations of the maths, the simple maths, and then advanced maths. Advanced mathematics can be like something that happen in, let's say, in your daily basis. Like for example, something like the mouse, for example. Okay, let's say the based on Newton's first law, say that an object will remain at rest or continue moving at constant velocity in a straight line unless a net external force acts on it. So for example, if I place this object on my arm, it stays at rest because the forces are balanced. Gravity pulls the object downward, and then my arm pulls upward with the normal force. If I push the object, it starts moving because I apply an external force. However, it does not keep moving forever because of friction acts on the opposite direction, right? I move that and the friction works in the opposite direction. Okay, friction is caused because the interaction between the surfaces of the object and the skin and my skin. Even if they look smooth and horizontal, they are not plane. At a microscopic level, both surfaces have tiny irregularities. These are like microscopic banks interact. So if we see with our own eye, we see like my arm is horizontal but not plane, and the object is the same. But at microscopic levels, there are some bumps that interact to each other, and this is what it forces the object to stop. So basically something like this but expressed by maths is what I will call advanced maths. That's something that I would like to see also in this channel. Maybe it's gonna be like the next material that we're gonna work with. Let's see. Okay, so basically the union and intersection is like pre-calculus, it's not like advanced math, and it is, you can also learn it just in here if we try. It can be a bit confused, but let's see. So you can also see that there is more things that you can do with Python. Let's say for example required sensors. Let's try make it make sense. Required sensors could be a set of camera. I've been writing camera wrong all the time. I've been writing camera with an A, which is Spanish. Okay, never mind, it's obviously. So we can put radar, we can put GPS, and we can put microphone. Okay, we have them. And now let's say installed sensors. And installed sensors is a set with camera again, radar also, but now let's say that we're gonna put a different one. We're gonna put like I don't know, let's put helmet, just to put something different. Okay, helmet. Okay, this is pretty obvious, right? Because of the variables. If all the variable name makes sense, basically a lot in the code is already easy to understand. So we have a set called required sensors. So basically those are the sensors that are required for a project. Let's say that we're working on a project and all those sensors are required, and so far we only installed camera, radar and helmet, which camera and radar, they were required to be installed, but the helmet no, and we installed helmet, but the helmet is not required. So this is why you can use union and intersection. And the way to see the union and intersection in Python, we can put like required sensors, and then we have this one, and we put installed sensors. Now after the print, we can explain what everything does. Let me just copy them and then we can explain them. Print required sensors, and now we can put an installed sensor. Okay, now we can do again required sensor minus installed sensors, and the last one, just to see the difference, it will be now installed sensors minus required sensors. So we make the print of it. Okay, we have 4 prints. What do we have in the first print? Radar, GPS, helmet, camera and microphone. But camera and microphone, camera and radar, they will repeat the values, and in here we have all the values. So basically the first one is an union. An union is all the values that are in one in A and in B, but without counting, in this case is without counting repeated values. So the union in here will be all the values that are the required sensors and installed sensors, but without counting them repeatedly. So all of them, but not repeated, because sets does not allow repeated, right? The second one we have in here, radar and camera. Okay, the second one is an intersection. The intersection is every value that is in A and also that is in B. In this case, every value that is in required sensor and also that is in installed sensor. Only the ones that are in both places, in the same, like in both variables. So GPS and microphone is not in installed sensors, and helmet is not in required sensors, only camera and radar. So that's what we got in here. And now we have required sensors minus the installed sensors, which is here GPS and microphone. GPS and microphone, because this one and this one are the same. And now if we do it otherwise, we can check helmet, which is the one, in this case, this one are the ones that are required and is not in the installed sensors, and this one is the one that is already installed but is not required. So this is something a bit more advanced, but it's a really helpful program. You don't need to memorize that right now, but just it's good to know that it exists, and there is more things that you can do with Python that could be really helpful. Okay, let's see if we can see something else. Okay, check if something is inside. We can do that because also it can give us a bit of a structure about what are we going to do next. So let's say sensor is gonna be a set of camera, radar and GPS. And now we want to know if something is inside of the set, because it can happen that, as I have said before, maybe we can have a set with 500 values, 600 values, and how will I know those 500 values? We don't know if something is inside of the set. So if, in this case we use if is a conditional, something can be true or something can be false. Conditional are booleans. You remember the booleans, true or false? We solve them on data types. Okay, if the value GPS in sensors, we put the colon here always. If not, it's not gonna work, but it happens to me accidentally a lot that I don't put the colon, so it's very easy to debugging, and because I'm 100% sure that it will happen during the class, during the video today, we will debug this. Okay, in this case, print, I will copy and then I will explain. GPS, we don't close it, available. Okay, now we put there else, print, and here could be like GPS not available, GPS not available. Okay, and now we say nothing else because the print is already in. Okay, so basically here we have a set with 3 values, and then we say if GPS in sensor, which is not because it's wrong, now it is right. If GPS, the value GPS in sensors, if this is a condition, if this is true, this can be only true or false. If GPS is not in condition, is not in sensors, is false. If GPS is in sensors, is in the set, is true. So only if this condition happens, then Python will say, okay, this one happened, when you want me to do next? Go to the indentation. The indentation is always 4 tabs. So 1, 2, 3 and 4 tabs. What it means that this line of code only belongs to this one, and this line of code only belongs to this one. So if this condition is true, then Python will say what you want me to do next, and then we say okay, I see an indentation, so I'm gonna check which line belongs to this condition. So I see an indentation, I go inside of the indentation, and what do you want me to do here? Print GPS available. Okay, if GPS is not in sensor, let's say the GPS is not in here, then it say okay, GPS is not in sensors. So I don't go to the indentation, I just gonna go out of this code, and if I see something on the same line, then I try else. Okay, it was not in GPS, what do you want me to do next? Else. Else is not like true or false, else is then whatever happens, print GPS not available. So if we print this, we see GPS available. Why? Because GPS is truly in sensors, so the condition is true. So Python say okay, if GPS is in sensor, which it is in sensor, found it, then I go to the indentation. What do you want me to do then? Print. Okay, then I just finish, I don't read anything else. But let's say that we have this, now this is false because this value is not in here, and we print GPS not available now because this condition is false, so it doesn't go to the indentation, it just keep to the next line and say okay, if this is not true, then just print this. Else basically is to cover the code to make sure that it doesn't break, because this condition can do only true or false, so you just say okay, if it is, print whatever, but just in case the condition is not true and the condition is not cannot be done, then just in case print this, so the program keep running and doesn't break. Okay, this is very helpful if you have a set with a lot of values. And now let's check this. Okay, we can, no, let's move to the loops. Now we're gonna see the loops. Okay, how can we do it here now? Let's do loops.py. This one, I'm really gonna try to explain it the way that I will have loved someone to explain it to me, because it can be a bit confused in the beginning. It's not really difficult. The first time that you see this, it's gonna look difficult. Every material that you go for the first time can be a whole different work, right? But after giving some time and keep trying and trying, it starts to make sense. And something that happened with this, I'm still at the beginning, but something that I could already realize that happened is like, first time that I encounter to an exercise that I don't know yet, or some theory or some new documentation that I don't know yet, the first time that I see is like, there is no way that I can just know this. But then I do 2, 3, 5 and 1,000 times, and after it's like I read it 500 times and I work with it 500 times, and it make no sense at all. I just do it somehow and it make no sense. But then I do it 5 times and 1, and this one I realize like, okay, makes sense. This is because of this and this is because of that, and it at the end it starts to make sense. But until we get to that point, take a long time. So just don't get frustrated, just watch the video as many times as you need, and at the end it will make sense. So let's start with the loop. Let's say the temperatures is equal to, let's make a list, and in the list we're gonna put 36. I'm gonna put different values. The values can be a bit tricky now. let's put 41, 37, 42 and 1. Okay, we have a list, and now we want to do a for loop. I'm gonna put the for loop and then I'm gonna explain what the for loop exactly does. It could look a bit confused, but I'm gonna try to explain it in a way that maybe you will get it pretty quick. If temperature is greater than 40, then I want to print. We should start watching the print with the format. I'm gonna try to put it without the format, and then we put it with the format, so we start to see the print with the format, because it looks much more presentable and could be useful in some cases. So let's put alert temperature, and then we can put that's why the format is better, because now here we have to do like a lot of stuff, like we have to open quotation marks, we have to close quotation marks, we have to put the variable, then we have the element, then we have to put the comma, open a different one. Could be a bit like confused. And then else, so if the condition is cannot be done, I want to print a different stuff. In this case, print normal. I'm gonna explain it now. Okay, we can put here the element and then sentence with it degree. Okay, this prints will work just like that. Okay, what is gonna do the loop in this case? Basically, what is a for loop? Because okay, a for loop, basically, how can I explain it so we can understand it? Because the definitions can be a bit tricky. Okay, the for loop will iterate, isn't it? Iteration, right? The for loop will iterate as many times, at least through list, okay? It will iterate through list as many times as values you have in the list. So let's say that you have 1, 2, 3, 4, and 5 different values on the list. So in this case, the for loop will go through it and will do an iteration on this list as many times as values you have in the list. This is basically the definition of the for loop. Iteration as many times as values in the list. If you have 200 times the for loop will iterate until the for loop happens. If you have 2 million values in the list, the same code is gonna do an iteration 2 million times until you force it to stop, or if not, if you don't force it to stop and you have 2 million values in the list, will iterate 2 million times until finish the list. After finish the list, it's done. Okay, now we check this. This is, I will say, it's like a formula, because in every single loop the formula is mostly the same. So it can be a bit confusing in the beginning, but the formula, you can put here 1 word, 2 words, we will see that later, but still doesn't matter how different the exercise will be, the formula, the structure of it will remain almost the same. So once you have it, then you will have even more complex exercises. So then here, let me try to translate what it is in here and what it exactly means. The way that I learned it myself, it was for every element, you see temperature, but this is not temperature. This is for every element, because if you see here is temperatures with S, it's plural, right? So we say that Python is really restricted with that. So this is this. This is not this and this because it's a different word. Okay, so for every element on the list, which is this is the list, for every element or value, the same element or value, for every element or value in temperatures, which this is actually the list, for every element or value in the list, it will go indented now because we have values. If the temperature is greater than 40, so if the element that you will be iterating right now, in this case they are all numbers, is greater than 40, then if this condition is true, it will go to the indentation and will print this. But if the element that is running, that is iterating at this moment, is not greater than 40, then the code will go out and find the next program, which is else, and then print this. There is no more condition, either it's true or it's false, right? In this case, because if it's true, we'll print this. We look at this before, and if it's false, we'll come to the else and we'll print the next. Okay, so now let's start with the first one. We said that a for loop iterates as many times as values in the list. So we have the first value, which is 36, and it will start with the first value, 36. So in this case is for 36 in the list, if 36 is greater than 40, print this. But 36 is not greater than 40, so it will say okay. Then I go to the next code, which is else. Whatever is not here, just do this. Print this. So in this case, with 36, we'll print this line. And now it will go to the next one. It will say, okay, I already finished the first iteration, so I'm gonna check if you have any other value, and it will do like this, and it will go, I found a second value, 41. I'm gonna start again. For 41 in the list, if 41 is greater than 40, oops, this condition is true, 41 is greater than 40. I'm gonna go to the indentation, print this, that's it. It's true, we print this. I'm ready to go to the next value. I'm gonna check again, it does like this, it come here, and it says 37. We have 37. Okay, I'm gonna do the iteration now with this number. For 37 in the list, if 37 is greater than 40, it's not greater than 40. I'm gonna check if you have something else for me, of else. With 37 I will print this then, because this is else, it's not true, the condition. I'm gonna check if you have one more. Let's say that we already do 42, and now 42 is greater, so it will go to that, then we will go back here, do the one. The one will say for one in list, if 1 is greater than 40, 1 is not greater than 40. I'm gonna check what else you want me to do. Print this. Okay, I'm going back, and oops, there is no more values to do. I already did everything. I go out. Okay, and now let's print this, and we have alert 41 degrees, alert 42 degrees, and then we only have like normal 1 degree, 36 degree, temperature 36. Why is in this case only shows 41, 42 and 1 degree? I'm a bit confused right now. No, it is inside. It is inside though. it should put like 36 also in here, but it's not iterating with 36. What is wrong here? What are we doing wrong? Let's delete now the 41 and 1. I'm going to delete this too. Why you always this too? Print me this. Now you print me 30. What is from here? We had 36, we had 41, we had 42, 37 and 1 I think we had, right? And 1. Let's try to print it. Okay, what's from now? 36, 41, 42, 37 and 1. Something is wrong that I cannot see. Let's do the list again. Let's say 35, 41, 42, 37 and 1. Why only saw these 3? Let's try to find what is the error, because there is something here that I cannot see though. What is exactly the error? Oh, okay, I could not really see the problem in here. That took long though. I know that it happens to the class. We didn't do the indentation in here. So basically, inside of the for loop, we want the if to work. Then inside of the if we have the print, but if the if is not working because this condition is not true, then the program will say that it go out and then it print the same. It's like, okay, if this condition is not true, what else you want me to do? I have to do something, right? Then go to the else and print this. But the else in this case was outside. It was part of the for loop. It was not part of the it was on the same line as the for loops, was not in the same line as the if. And we want the conditionals here, we want the condition to be done. If we print now, we have them all here. That took long, no, I was like, I could not see that. So you see, this is very normal. I have been doing for loops for like 6 months, and you see it always happens. Like, to have a mistake is so easy. It's so easy and so common. And there is things that it takes time. It was just 8 lines in here. So we had like this problem for like at least 10 minutes that I didn't know how to solve it, and it was 8 lines. So that's what I said yesterday, that you should put every 10-15 lines a check. Because imagine if this happens in 200 lines of code, you get crazy. It's like, how I'm supposed to fix that. So to avoid these kind of things, go to major problems just every 10-15 lines to check. Overall, if you're still a beginning like me, like I will never try to do a code over 50 lines without a single check. It's like I will go crazy if there is something going wrong. It will take ages to figure it out. Okay, so we got the main ideas, but I want to show you also the print with the formatting, because it's good that we start to see print with formatting. That's not what I wanted to do. Okay, so print with formatting we do like this. We already saw in the last class once, I think, right? We open the strings, and now everything that we're gonna put is gonna be inside of the string. We put alert. We can put this one, and then we open the curly brace. Remember, for the formatting is always the curly braces, and we put here temperature, which is the element that is going to iterate. Say alert. Oops. So alert will be colon, it will be 36 or whatever it is, 35 degree. In this case will be 41. Please run. Let's make this scare the customer. Okay, so you get the main idea basically. So basically in this print, you see, and now all we have to do is to put the F that I always like it to put at the end, because I like to see how it changes. You see temperature is in red. It's like I like to see like it's blocked. It's like, hey, the formatting is not gonna work because it's work, and then I see that it changed now, and it's just one single quotation marks, and you put everything. And the main thing, which is the element into this the curly braces. Let's say that in different prints it's gonna be a variable, if it's gonna be whatever. The main thing in the curly braces, the rest is everything inside the quotation marks. That's why I like it much more. It's like much more not elegant, but you know, it's like if you start to make prints like this, it's like you are already understanding a bit more about coding. Let's put print here. We open the quotation marks and we say normal, and now we open, we put the element, we close it, and we say don't panic, everything under control. Okay, and now it's blocked, it's red, now it's working, and we print this. So we have it in here. Alert 41 degree, please run. Alert 42 degree, please run. And then with the 37 and 1, don't panic. You see, in here we have to open the quotation marks, we have to put the comma, we have to put then the variable or the element, we have to put another comma, open another quotation marks, close the quotation marks. And this for a simple line of coding like printing. Imagine that you want to put more stuff, or there is like 2 or 3 different variables. It's like how many commas and how many quotation marks you have to open and close. In this case it's like more straight, more like just elegant at once, all of it. I just like it more, and it's useful sometimes. We will see maybe with the parameter, with the functions we will see. Okay, what we were doing even. Okay, so this is kind of clear, no? Let's complicate it a bit more. Okay, we have here temperatures, and then we are gonna create a variable saying alerts, but the alert is gonna be a total count of 0. And now we're gonna start creating a for loops, and we're gonna say for every element in the list, if the element that you're gonna be iterating at the moment is greater than 40, colon, then alert is going to be the same variable alerts, no problem, that doesn't change, but it's gonna be the same variable plus 1 in the counter. This is a counter. This variable is called a variable equals 0, but in this case it means it's a counter, and we will see why. So now we will print it. I'm gonna explain it, but let's put here the print. I'm gonna keep doing the normal print, the print with the format a few more times so we can really see the differences between. So let's say in here I want to print number of alerts equal, we have to put space in here. You see, this can be a bit tricky. Now we have to put an extra space there. Now alert, which is gonna be the variable, and then let's see, that could be enough. Let's not complicate it. Okay, what do we have in here? We have a list, and then in the list we say let's create a variable. The variable is gonna be alerts equal to 0, and now we say for every element in the list, if the element is greater than 40, if this condition is true, it will go to the indentation. It's like Python is okay. If this happens, then I go to the indentation. What you want me to do next? I want alerts to be equal alerts, like it doesn't change. I want the variable alerts be the variable alerts but plus 1. This only if the condition this is true, only if the condition, if the element is greater than 40. If not nothing happen. If not, it will just go to the next one. There is no, we didn't put any else, we didn't put nothing, we just want to count. So 35, it will come here. Okay, for 35 in the list, if 35 is greater than 40, it's not even greater than 40. What else you want me to do? Nothing. Okay, I go to the next one then, because it doesn't go to that one. It just see inside. Okay, there is nothing here. Okay, then I go back to here. And 41. For 41 in the list, if 41 is greater than 40, it is. What you want me to do? In this case, you go here and say, I want the variable alerts to be alerts plus 1. And you say, okay, do you have this variable? Yes. The variable is equal to 0, but you want to be, if the condition is true, you want to be the alerts, whatever you have here, plus 1. Okay, easy. So alerts now is not 0, alerts is gonna be 1. And then it goes to the 42, because we already finished with the 41. So you say, okay, I'm gonna check if you have more values. The next value in the list is 42. For 42 in the list, if 42 is greater than 40, I want alerts to be alerts plus 1. And you say, okay, 42 is greater than 40. I'm gonna make this. I'm gonna come back here, and then say, okay, but alerts is already 1 because the previously value was 41. So now it's gonna be another 1. So 1 plus 1, 2. Say, okay, now alerts is gonna be 2. Say, okay, do you have more? 37. It doesn't run. Go back 1. Say for 1 in the list, if 1 is greater than 40, it's not. So we just say okay, you have no more values, what else you want me to do, and it check to the print. There is nothing else like below the print, so the full code ends in here, right? And we print, and we say number of alerts equal to. Why 2? Because we saw it in here. With the 41 it added 1, and with the 42 it added another 1. 1 plus 1 is 2. With this one, and this one, this condition was false, so the indentation was not even trying. It was just running to the next value, and the next value, and the next value. This one was only running if the condition is true, which is only 2 times. Okay, and now we can say here, oh yeah, print don't like this. I don't know how to take. I need to learn how to take documentation. I don't want to read documentation. I just want to see my code. Number of alerts. We open the curly braces and we put the element temperature. We close the curly braces. That's it. And now we put the F on the beginning. And now it changes and we print. And now it says 1. Why it says 1 now? Did we change anything? That was even wrong, but it doesn't matter, that's not the problem. Number of alerts 1. Why? We have 35, 41, 42. It makes no sense at all. Okay, yeah, makes sense. We don't want to print temperature, we want to print alerts. No, we have it. We were not printing the variable alerts. That was the whole point of the exercise, and I was just printing a different thing. But now I'm curious why temperature gives 1. Why if I do the I don't want to cause confusion, so I'm gonna do like this. But I'm curious and I want to know, so I'm gonna put it here. Good job. Okay. Can you just please print? What am I doing? Thank you. Okay, why it was with temperature doing that? It was saying so in 1 number of alert. This number of alert doesn't count. This is just like something to give some sense to the phrase, but in this case it doesn't. But I want to know what interpreter is. Print 1. Like, we have the values in here. Maybe the only sense that I could find in here is that if we put temperature, which is wrong, you never put temperature, you put the counter in here, and the counter in this case we give it the name of the variable alerts. Okay, this is just a mistake that I did, but it's showing 1, and I'm curious, and I think that maybe showing 1 because temperature in this case is, as I say, this is the value or the element that is iterating at the moment, but it only iterates 1 per loop. So in 1 loop it iterates 1, in the second loop it iterates 1, in the third loop it iterates 1. So maybe that's why it's 1, because the for loop only iterates 1 element per loop. That's the only sense that I could find for that. Anyways, we keep moving. We already saw that. Okay, let's move to the accumulators. An accumulator stores a progressive sum. for example, to calculate an average manually. So let's say, let's put these values on battery. It's gonna be, let's put different ones. Let's put 100, let's put 50, let's put 10, and let's put 5. Let's make an easy one. Okay. And now we create another value, which is like a content. In this case, it's more like a accumulator, but it's the same. And we put sum total equal to 0. Why equal to 0? Because it's gonna be easier. You can put equal to 10, equal to 20, but equal to 0, so we start from 0 and everything will make sense, right? So for battery, I'm gonna read it, I'm gonna read it the way that I will understand. For every element in the list, which is batteries, I want sum total to be exactly the same, sum total, but with the only difference that I want an addition of the element. And then I want a variable called average to be sum total divided by the len. You remember the len? The len was the total of the values that a list contains, right? Batteries, I will explain now anyways. And then here we say print battery average Okay, what it does, this is just basically the average. The average in maths without using Python is much more simple, right? You take the calculation if you need it and you say, okay, the average calculation is the total additions of the numbers inside of the problem divided by the number of the values. So in this case it will be the total addition of this divided by the number of the values, which is 1, 2, 3, and 4. But we want to do this using Python. How do we do that? We create a variable which is 0, and we say for every element in batteries, for every element in the list, I want this variable be the same one but with the addition of the element. So Python say, okay, no problem, you have 100. For 100 in the list, you want the variable to be the variable plus the addition of the element. The element is 100 in this case. So okay, now this one is 100. This is done. Let's Python check the second value. For 50 in the list, this variable is gonna be this variable plus 50. We go back here, we say, hey, now this variable was 100 plus 50 is 150, 150, right? It does the same with 10 and it does the same with the 5. And now the program is done, but we have another variable here that we're gonna call variable average. And the average is gonna be this variable, the value of this variable, which is this one, and now this one is not 0, right? After the for loops, this value is gonna be the addition of all of them because of the iterations, right, that we just did. So it's gonna be the total additions divided by the length of the list. And the length of the list, we know length is how many values you find in this list, which is 4. So it's gonna be the total addition divided by 4, and this is how you calculate the average. You print this, we have a problem here because we don't have, oh, we did it we did it wrong. I mean, it is right, but it is good that this happened because now I can explain to you one thing. So you see, for battery, because it will be like this to make sense, right? So let's put in this case batteries. Okay, now it's all work. Okay, the average is 41.25. Now I'm gonna explain to you what happened exactly in here and why this is like makes sense if you put it like this, but what is the difference if we change it? So we call it and then we receive the average, which is that we already explained it. Now what happened in here, basically, as we say, this is supposed to be the element and this is supposed to be the list, but in here I was not typing the list. That's why it was a mistake in here, because I was putting this, but in this moment it was called different. Let's say this one I want to call it track. For track in batteries, this is sum total plus track. Make no sense at all, right? And now what else? Up here, that's it. So for track in batteries, the sum total is gonna be the sum total plus track, and we print and we have exactly the same. Let's say here I want, I don't know, for iPhone 17 in batteries, 0 cent, right? iPhone 17 41.25. Now I want this, which and this I wanted here, 41.25. That's why I say that this, the way that you could understand, is for every element in the list, this is how you read it, because as you can see right now we can put everything in here, like everything in battery, so you just do the coding fast. But if someone else come and read your code, it's like you can do a better documentation, you know, just try to make it make a bit more sense. So because if doing everything just perfect, it is so easy to make a mistake. Imagine if then you're doing things uncommon, you know, things that are uncommon, then it could be like double easy to make a mistake and it could be chaotic. Okay. We could see the zip. So we see the zip. Let's see, because we saw it with the it's like, I will say also this is kind of like more advanced, using the folder for that, because but okay, let's do it. Okay, let's see that we have batteries in there. We change it, let's change it for sensors. It is good that you can see what things can you do with Python, but I don't want to complicate this so much right now. Temperature, then we can do battery, and pressure. Okay, now we can say readings are going to be 38, 85, and 1.02, and we'll close it. Okay, we have two lists in here. One list called sensors with 3 values and another list called readings with 3 values. And we say for sensor, for element in the first position. Okay, I'm gonna read it as it will work so we understand. For elements in the first position, an element in the second position, I want in the list, that I'm gonna put the list now. Okay, let's put the list and then I put this one. I want in sensors and readings I have to do the indentation because I didn't put the thing that I want to put. Print. Let's try to do this without the formatting. Then without the formatting will be simple like sensors and without the string. Sensors reading. Just like that. Okay, we want to do something in here. For the first element in the first element in the first list and the second element in the second list, in the first list and the second list, I want to do something. What I want to do? I want to do zip. Zip is another function word. Basically, it also like map. It's like a map. It will be mapping. But it's a function word, so every function word go with parentheses, right? So we put parentheses and we put the list into the parentheses. And then we put the colon. So for the first element of the first and the second element, I want in to sleep to the zip and then print, and we see but I'm a bit confused because it isn't two different. I'm not sure if it will be like this or if it will be like more like mapping, because this is just really like two lists. I'm not sure if it will be like this though. Let me just check the exercise. Like, what did we do in here? That should be just like this. What about if we do this? Nothing will change. I thought that it would be more like I don't remember if we did it with the list or with the tuples, with the tuples, right? When we were unpacking the tuples. Remember that we were creating like 3 variables and then every variable was 2 different. I really thought that it would be more like that, but it basically just print the order of one and the order of the second one just in the same line. Which make kind of sense or not? No, because it's the same thing 3 times, no? So we check if something is wrong in there. Maybe it's just like that, you know, but I don't see the sense of it right now. Okay, it's because we printed the variables list instead of printing the element. It should have been like sensor and reading. We should have printed the element instead of printing the variable. And now it's mapping its temperature 38, battery 85 and pressure 102. That was the mistake. System is exactly as I was saying with the tuples. Like when we were unpacking the tuples, now it's exactly the same. So the first element go to the first one, the second go to the second, and the third to the third in both of the list. Okay. Let's see if we can do something else with this, or we just go to the functions. Okay, this was the for loops. I think it's now too many things, it's a bit confused, but as I said before, you see, now in this case we have two. I remember that we started just to put in one single word, and now we have two, but the structure, it's mostly always the same. It really doesn't change. Okay. What is a function? A function can receive not only a number, but it can also receive lists, tuples, sets, and dictionaries. Dictionaries we will see in the last class. Today we will finish with the functions. The last class will be only dictionaries. Maybe we'll do like a review of everything, a quick review, but it will be more focused on dictionaries. Okay, sets and dictionary, and okay, let's move functions. Let's put functions here. Functions dot py. Okay, I think this function is a bit confused to start with. But okay, let's see. Maybe if we start with the difficult ones, then once we do the easy ones, will be even better. So let's put every function start like this, which is called like the definition of the functions, whatever. But every function start with definition, which is def, and then calculate average. I'm gonna explain it now. Readings. Okay, this is the first line of a function. Basically, it's the definition of a name, whatever name I want. This is like a variable with a parameter. Okay, the function is we create a variable and we give a parameter. It can be 1, 2, 3, but in this case it's 1. So again, definition, we create a variable and we give parameter. This is like the for loop is for. It's something that will change, but we have to put something here to make it make sense. Okay, in this case it's gonna be readings, and it will make sense later why it's reading. And let's do the average again. So we say the variable average is gonna be sum readings. So sums the addition of the parameter, that the parameter will come later, we will see, divided by the length of the parameters. And now here we say we say return average. Why return average? Because average is this variable, and this variable contains this operation. So basically we already did variables, and when you print the variable, you print the value of the variable. In this case, the value of the variable is an operation, and after we do the function is something, it's like a code that you create and then you can call it later. It will make sense later. Let's keep moving so you can check temperatures. Now let's create a list called temperature, and we put 36, 37 and 38. Okay, and now we say I want a variable called result, which is gonna be the variable that we did before, calculate average. Okay, result is gonna be the definition, remember this one, calculate average plus a parameter. Here we have to add something, and the parameters that we will add in here, it will affect to the result of this operation, right? So result is gonna be calculate average, and in the parameters we're gonna add an argument. This is how it is called. This is called parameters and argument. In this case, the argument is gonna be temperature. So basically the parameter that we give to the function it's called argument, but in the definition it is called parameters. So we give arguments to the parameters, and now these values, it will be in here and it will operate with these values. Let's do the print, and then we see print result. Okay, what will happen in here? We say create a function with this name and one parameter. Now inside of the function, I want the function to be like, I want to create a variable called average, and the value of average is gonna be the total addition of the parameters that later we will give, divided by the len. You remember the len is the total of the values that it will be added on the argument later. This is still a parameter. And now we'll create a list with 3 different values. Okay, so far so good. And then we'll create a variable called result, because we need to put something in something, right? I skip this, I'm gonna explain it now. And in here we say the variable result. In the variable result, I'm gonna store it, the function, with the argument of this list. Why the return average in the definition, in the function? Because without this, the function will just run just fine, but will not return this value. That's why we put in return this variable. If we don't put in here return this variable, this does the operation, but then just keep it. Even if you put the print in here, it doesn't work. So when you do an operation, you always have to call it inside of the function. So this is basically saying every time someone will call the function, doesn't matter what the argument will be, return this one. And this one already stores the operation with the parameters that later will be assigned to arguments. In this case, temperatures. Where was the mistake? Calculate average. In the line 8 was the mistake. Calculate average is not defined. Okay. Calculate. So the average is 37.0. why it is 37.0 and not just 37, why this is giving me a float number and not an integer, because we have a division, and we already said in the first class that every division with the single slash will be float. Doesn't matter if the result could be perfectly an integer, it will give as a result a float. It's confusing right now because this exercise is actually complex for the first time to see the functions, but we're gonna see easier examples that is gonna be much more understandable. Let's do okay, let's do one more complex one, and then we will see another one easier to understand, and then we will see maybe one just doing everything we have seen so far. Okay, this one could be a bit complicated, but we will go through it. Okay, the same. We create a function, and a function is gonna be count high temperatures. And then we're gonna give only one parameter. And we say we're gonna create a variable called alerts with the value of 0 so far. And then inside of the function, because you see the indentation in here, we are still inside. If I write in here, I'm outside of the function, but everything that will be from here forward, everything will belong just to the function, not to everything that you will put in here. So we're gonna still inside of the function, and inside of the function I'm gonna do for loop, and I'm gonna say for every element in temperatures, which is the parameter, for every element in the future argument, because right now this is a parameter, so for every element in the parameter, if the element is greater than 40, alerts will be the same variable, alerts plus 1. And now in the for loop we go outside of the if, and we go not outside enough to reach the definition, the function, to go outside of the function, so we're still inside of the function, and inside of the function we want to return alerts, because the counter is the thing that we want. That's why we created this. Okay, this is the function. The function is in this number, this name, with this parameter. I want to create a variable, but the variable will start with the value of 0. This is just simple, right? We just create a function, we give one parameter, and we create a variable starting from 0. And then inside of the function we're gonna create a for loop, and we're gonna say for every element that will be in the parameter, if any of this element will be greater than 40, I want the variable alerts to be alerts plus 1. We already did this. And now, before we exit the function, remember that we need to return the operation that we want. With operation we want, in this case, we will want alert to see how many alerts can we make. So return the alerts, and now we give the argument, because we don't have an argument yet, we only have parameters, and it doesn't work with parameters, it has to work with argument that later will be assigned to the to the parameters. And now we create a list which is gonna be readings, and the list can be 36, 41, 39 and 42. Okay, and now we want to print. Let's make a print, and we put the name of the function, which was this one, right? This one. But same as we did in the other exercise, in this case the argument that we're going to pass to the parameters is going to be the name of the list readings. Reading. What are we saying in here? We are already explaining the function. What are we saying in here? We are creating a list, and we have a list, and now we want to see on the console the function with the parameters. In this case is the argument, with the argument of this list, pass it as the parameters. Okay, yeah, so because of the print and the, okay, we print this. What is the error now? Can I type? Okay, some typos that we did in there. So 2, it prints 2. Why it prints 2? Because there was a for loop inside of the function, right? And we pass these arguments as parameters. And then what it did? It did like, okay, you want in this function this argument. Remember that if we only have in the function one parameter, we can only pass one argument. If we pass 2 arguments in here, let's say that you want here reading, and there is another, imagine that there is another list called list. Okay, if you pass 2 arguments into one parameter, it will be a mistake. It will say something like, hey, I was expecting 2 parameters because you passed me 2 different arguments, but I only see 1 parameter. We can see this example in the exercise that we're gonna do before. We're gonna make a really easy exercise to understand this a bit more. So moving forward, what does it do? Basically take the 36 and we say, okay, for every element in the list reading, because now reading, the list reading is the argument that it went to the parameter. So for every element in the list, if the element is greater than 40, I want this variable to be counted plus 1. 36 is not greater than 40, so it just moved to the next one. 41 is greater than 40, so it added 1 in here. 39 not greater than 40, so it just escaped to the last one, and it said 42. 42 is greater than 40, so I'm gonna put 1 in here, but there was already 1. 1 plus 1 is 2, and if we print this, we see 2. Okay, let's check one easy one, and we can see one easy one. Okay, this one is pretty easy, so we can understand. Okay, now this one shouldn't be a problem. We're gonna create a function, and a function is gonna be calculate sum. It's gonna be calculate sum. Okay, this is not gonna do anything at all. This is just a name that will make sense to the operation that we're gonna do later. But in the definition, the variable that you want to assign could be called whatever. You can call this truck, you can call this car, you can call this table, whatever you want. But it will make sense if we put calculate sum because we're gonna do an addition, right? So calculate sum, I'm gonna put number 1 as parameter and number 2 number 1, number 2. Okay, what we did in here, we just create a variable, a function with 2 parameters. Number 1 and number 2 are just 2 parameters. I could put here a and x, a and b, c and a, car and truck, doesn't matter. I just put number 1 and number 2 because it will make sense to the calculation that we're going to do. And then result. The result, the variable result, I want it to be number 1, let's say parameter 1 plus the parameter 2. We still don't know the parameter will come later, right? Number 2. So parameter 1 and parameter 2. Then okay, then I want to print result, which is just the variable, right? I'm gonna go outside. Let's do just this because this is something to see now. Calculate sum. Okay, I will explain it later now. So we did a function, we call it calculate sum, and we added 2 parameters. What means that there is 2 parameters? It means that if later I want to call this function, I will need 2 arguments. For 2 parameters, you need 2 arguments. Inside of the function, I create a variable called result. And the result, I want to store it, the operation, which is gonna be parameter 1, whatever it is, plus parameter 2, whatever it is. And then inside of the function, already inside of the function, I want the result to be printed. So let's say we make this and this, you know, there is a lot of coding that we did already. But we're gonna put it as comment so it doesn't affect. And now in line 29, this is really the definition of the function, that you can create something, you can create a coding. This is a coding, okay, and a coding that you can use later. This is the definition of the function. And let's say that, okay, I remember that I used to have a function for additions, but in order to use the function, I need to call the function, right? So let's take these 3 out so we can see. Okay, so I say calculate sum because I remember that I created a function called calculate sum if I want to make additions, but I remember the calculate sum I created with 2 parameters, so I have to give 2 arguments, and the arguments can be 10 and 5. Okay, so now I print. Why I print without put any print here? Because I'm calling a function with 2 arguments. I'm just calling a function that inside of the function there is a print already. So I don't need to put the print in here because there is a print already inside of the function. So every time I call this with the 2 arguments, if there is 2 parameters, or 5 arguments if there is 5 parameters, it will be done. This condition will be done. And if we calculate, you see 15. And you can keep going and go to the line 500. If you have 500 lines of code, you call this, and if the conditions are true, if you have 2 parameters, two arguments for 2 parameters, and you call it right, you will have this operation. The reason why it's also good to have this is, imagine that you have to do 200 different these 200 times, so you don't have to create this 200 times, right? You just call the function, because in this case, okay, it's a small program, but let's say that the program that we did before with the average, and let's say that you have 200 lists or 500 lists to do the average. Are you going to do 500 different codes for 500 different lists? You create a function and you pass the parameters of these 500 lists. So in one line of code, you had 10 or 12 lines of codes. So this is the reason for that. Now let's check one last exercise before we finish, that we're gonna check a bit of everything that we have, but an easy one. I don't want this to be so complicated. Let's put like the definition, check temperature. And check temperature, this is a function. I'm gonna pass one parameter. Temperature is gonna be one parameter. And then we say if the parameter that we will give is greater than 30, I want to print high temperature. That's it, very simple. But I don't want to be now like true or false and say to Python, hey, I want this. If it doesn't work, then go to the next one. I want to create more things, more lines of code. I can put in this case elif. Elif is something between the if and the else. The if the starting, and the else is the end of the code, right? When you just want to make sure that the code will end, you just put the else, and whatever is not done in the first line will be done in the else. Okay, in elif it's like another condition, like if something is not, if temperature in this case is greater than 30, print this. Otherwise, elif temperature, so if plus else, the argument is greater or equal to 15, print normal temperature. And now we want to exit with something. So else, if this is the first one is not done and the second one is not done, then you just finish the program with else saying print low temperature. And now we call the functions. Okay, we call the function giving a parameter. Okay, we have one parameter, so we have to put one argument. We can put in here 35, in here we can put 20, and in here just 5, so we can do both. Okay, and now we can print. Remember that we don't need to put the prints in here, because we are calling functions that they already have prints inside, so the prints will be done inside of the function. And we print, and we have a mistake. Where is the mistake here? Oh, you see, I actually in the last exercise, this one I forgot the column. You see, it say in the line number 1 something is missing here, and then there's a system error expected column, so it's pretty straightforward to what you need. So we print and we receive high temperature, normal temperature, and low temperature. Why? Because of the 35, it was the first one, and 35 was the argument for the parameter, right? So now we can say if 35 is greater than 30, is greater than 30, then print high temperature. So 35 is greater than 30. So what it does, it just come inside of the leaf and then print this. And then just because the condition is done, you just go to the next one. You say, okay, you just go out of the program and then you call the function again, but this time with the argument 20. Okay, let's do it again. If the argument, if 20 is greater than 30, is now greater than 30, so I'm not even going to do this. And then the program goes to elif. If the temperature is greater, if 20 is greater than or equal to 15, yeah, I'm not gonna read anything else because this is actually a true condition. This is what Python thinks, right? So it go inside here and then print normal temperature, which was this one. And then it just go outside and he say edit this. Okay, you're calling this number 5. Now you say okay, then if 5 is greater than 30, it's not greater than 30, I'm gonna skip it. Elif 5 is greater than or equal to 15, is not, so I'm not even going to read the line, and Python go ahead. This is actually what Python does. Then say okay, if it was not in here, this is an else, I'm gonna do whatever it is in here. So in here we say print low temperature, and printed low temperature. So this is basically the function on how the loops works. I think for basic Python that's enough. Maybe we do one more class and we check the dictionaries, which I find them kind of complex. That's why I wanted to do it in just one class, and then maybe we do some review. But that's okay for today.